Hello and welcome back to Tech and EduSpark Hub, where technology meets education. In today's video, we'll be looking at the continuity of a function. So please, before you watch this video, keep supporting us by liking this video, hit the subscribe button and turn on the notification bell so you won't miss any updates from Tech and EduSpark Hub. And stick with me till the end and let's enjoy the best out of the lesson. So what do we understand by the continuity of a function? So before that, let's look at the condition for continuity. So for condition for continuity, let's say we have a function which is f of x. We can say this function which is f of x is continuous at x equal to a if f of a is equal to the limit of f of x as x approaches a. So this formula is known as the condition for continuity. So the condition for continuity states that a function f of x is continuous at x equal to a if f of a is equal to the limit of f of x as x approaches a. So what this means is that if we are given a function which is f of x and we are given the tend which is x equal to a, so for this function to be continuous, we have to substitute this a into this function. So it will now give us f of a. So when we substitute that, we will write our value or the answer that we get. And also after that, we will look for the limit of the function and we will input a as our x. And if the answer is the same, if f of a is equal to the limit of f of x at x tends to a, we can say the function is continuous. But if the answer is not the same, we can say the function is discontinuous. So let's look at some examples and see how this continuity of a function works. And moving to the first example as written on the board, the question says, check the continuity of f of x equal to x squared minus 4 all over x minus 2 at x equals to 2. So how do we know the continuity of this function? Remember that I said a function f of x is continuous at x equal to a if f of a is equal to the limit of f of x at x tends to a. So what this means is that we have to get our f of a first, and also we have to find the limit of the function, which is the limit of f of x at x tends to a. So how do we get this f of a? So in order to get this f of a, we have to change this x to a. And we know that from our question, you can see that we have x equal to a here. So we can see in our question, our a is 2 in this case. So x equal to 2. So in this case, we have to find the f of a. So we can just easily substitute our f of a as f of 2. Because from the question, a is equal to 2. So our f of a is the same thing as f of 2. So in order to find this f of a, which is f of 2, we can just say f of 2 is equal to, so it is as simple as substituting 2 directly to this function. So we can just put 2 directly anywhere we see what? X. So we can say 2 raised to power 2 minus 4 all over 2 minus 2. So in solving for that, we will get 2 raised to power 2 will give us 4. So we have 4 minus 4 divided by, so 2 minus 2 will give us 0. And also 4 minus 4 will give us what? 0. So we have 0 over 0. And we say if we have anything that has its denominator to be 0, we'll get our undefined as our answer. So we can say f of 2 or f of a is equal to undefined, which is also known as infinity. So this is what we get for f of a. So the next step is to find the limit of f of x. So in order to find the limit, so we know that our f of x is equal to, so what do we have here? We have x squared minus 4 all over x minus 2. So this is what we have for our f of x. So in order to solve this question, in order to find the limit, we can use several methods of limits. You can use the L'Hopital's rule, and you can use the direct substitution method by factorizing this limit. But I will be using the L'Hopital's rule in this case. And if you don't know how to use the L'Hopital's rule, I will drop a link in this video description. You can check the link and see how we get the L'Hopital's rule. So I'll be using the L'Hopital's rule in this case. So in order to use the L'Hopital's rule, remember I said we have to differentiate everything that we have in this function. So whenever we want to differentiate, the power will come to the front and the power will be subtracted by 1. So in this case, we have, so if we differentiate x squared, we are going to have something like 2 multiplied by x raised to power 2 minus 1. And this will give us what? 2x raised to power 1. And anything raised to power 1 is that thing, so we have 2x. So this is our final answer if we differentiate 2x. So remember, the power will come to the front and the power will be subtracted by 1. So this is what we are going to get. So in this case, when we differentiate x squared, we get 2 minus. So if you differentiate a constant, you are going to get 0. That is the general knowledge for a constant. If you differentiate a constant, you are going to get 0. And also we have all over. So when we differentiate x, what are we going to get? So in this case, remember that x is the same thing as x raised to power 1, because anything raised to power 1 is that thing. So the power will come to the front. We have 1 multiplied by x raised to power 1 minus 1. So therefore, we are going to have x raised to power 0. And anything raised to power 0 is 1. So we are going to have, so this is 2x, sorry, because when we differentiate, we get 2x. So we are going to have 1 minus, this is another constant. So when we differentiate another constant, we are going to get 0. So our final differentiation will give us what? 2x over 1, which is equal to 2x. So we can now take the limit, which is x tends to a. We know that our a is what? Our a is 2 in this case. So we can take the limit. So we can say f of x is equal to 2 open brackets. What is our a? Our a is 2. So we can put 2, which is our x. So x is the same thing as a. So x is equal to 2. So we can put 2 in this case. So our f of x will be equal to 4. So looking at this solving, you can see our f of a is equal to infinity and our f of x is equal to 4. So we can now say f of a is not equal to f of x. So we can say this function is discontinuous. So this function is not continuous because what? F of a is not equal to the limit of f of x as x tends to a. So this is how we get the function is discontinuous. So this is how you solve continuity of a function. You just have to find your f of a first and also find the limit of the function. So the f of a, you just substitute what you are given directly to the question, and whatever you get, you find the limit and also do your method of limits and substitute. And if the answer is the same, you say the function is continuous. But if the answer is not the same, you say the function is what? Discontinuous. So let's look at another example still on the continuity of a function. And moving to the second example as written on the board, the question says check the continuity of f of x equal to x squared minus 4 plus 3 all over x squared minus 9. And the first condition that we have here, it says x must not be equal to 3. And also the second condition says x is equal to 3. So what this is basically telling us is just that the first condition is very clear, because if x is equal to 3 and we substitute x to this expression, we are going to have 3 squared minus 9, and finally we are going to have 9 minus 9, which will give us what? 0 as our denominator. And when we do that, we are going to get undefined or indeterminate answer. So this first condition is very clear. And the second condition, which is x equal to 3, what we are expected to do here is to find the limits of this function, and after finding the limits, we substitute x to be equal to 3. And if we get our final answer to equal to 1 over 3, we are going to say the function is continuous. So this is a simple way of solving this question. So what you just have to do is to find the limits of this function, and when you find the limits, you are going to substitute x equal to 3 or x equal to whatever you have here. And if your final answer gives you 1 over 3 or whatever you have here, you can say the function is continuous. But if your answer gives you something that is not equal to whatever you have here, you can say the function is discontinuous. So that is how you solve question in this format. So the first example that we did earlier is another format of continuity of a function. So this is another format that you can have your question. So you can have your question in this format. So the easiest way to solve this is by taking the limits and substituting. And if your final answer is equal to whatever you have here, you are going to say the function is what? Continuous. But if it is not equal to whatever you have here, you are going to say the function is discontinuous. So let's solve this and see how this works. So we know that our f of x is equal to, so we have x squared minus 4x plus 3 all over x square minus 9. So if we want to solve the limits of this function, we can use the substitution method by factorizing this quadratic equation and also factorizing this as difference of 2 square. But that will take us a long time. So I'll be using the L'Hopital's method of limit to solve this limit of this function. So if you don't know how to solve the limit of a function using the L'Hopital's method, you can check the link in the description of this video to check the lesson where we talk about the L'Hopital's method of limits. So in order to solve this question using the L'Hopital's method, remember that I said we are going to differentiate everything that we have in the function, and after differentiating we are going to substitute whatever we have in the question. So in order to do this, we are going to differentiate x squared. So when we differentiate x squared, we are going to get 2x, because when you differentiate the power, which is 2, will come to the front, multiply by x raised to power 2 minus 1, and you have 2x raised to power 1, which will give us what? 2x. So that is how we have 2x in this case. So you can check this lesson out in the limits of a function. So we have minus. So when you differentiate 4x, you are going to get 4, because why? If we have 4x, 4x is the same thing as 4x raised to power 1, because anything raised to power 1 is that thing. So 4x raised to power 1 is the same thing as 4x. So the power will come to the front, which is 1 multiplied by 4x raised to power 1 minus 1, and we will have 4x raised to power 0. So anything raised to power 0 is 1. So we have 4. So that is how we get 4. And when you differentiate a constant, which is plus 3 in this case, you are going to get 0. So we have plus 0 all over. So when you differentiate x squared, you are going to get 2x. And of course, when you differentiate the constant, you are going to get 0. So in this case, we have our final limit of a function to be equal to 2x minus 4 all over 2x. So we know that our x is equal to 3. So we can then substitute x to be equal to 3. That means anywhere we see x, we are going to put 3. So in doing this, we have 2 open bracket 3 minus 4 all over 2 open bracket 3. So 2 multiplied by 3 will give us 6. So we have 6 minus 4 all over. So 2 multiplied by 3 will give us what? 6. So therefore, we have 6 minus 4, which will give us what? 2 all over 6. And 2 all over 6 is the same thing as, so we can say our f of x to be equal to 1 over 3. Because this can cancel this to give us 1, and this can cancel this to give us 3. So 1 over 3 is correct to this limit of a function. So we can see that our f of x, which is 1 over 3, is the same thing as what we have in the question, which is 1 over 3. So we can now see that this function is continuous. So the function is continuous because our answer in the question is the same thing as the f of x that we get in this solving. So we can say the function is continuous. But assuming that if we find the limit of this function and the answer is not equal to what we have here, we can say the function is discontinuous. So this is how you solve questions in this format. So let's look at the last example on the continuity of a function. And moving to the last example as written on the board, the question says, check the continuity of f of x equal to x squared minus 4x plus 3 all over x squared minus 1. And the first condition that we have, it says that x must not be equal to 1, while the second condition says x is equal to 1. So like I said earlier, this question or this format is very, very straightforward. Because why? If x is equal to 1, you are going to have 1 squared minus 1, and that will give you 0 as your denominator. And in doing this, you are going to get undefined or indeterminate answer. So the easiest way to solve this is by taking the limit of this function. And when you take the limit, you substitute x to be 1. And if your final answer gives you 2, you can say the function is what? Continuous. But if the final answer is not equal to 2, you can say the function is discontinuous. So let's solve this question by taking the limits. So we know that our f of x is equal to, so we have x squared minus 4x plus 3 all over x squared minus 1. So when you take the limits, we'll be using the L'Hopital's rule by differentiating everything in this expression. And when you differentiate everything, we are going to substitute x to be 1. And your final answer, if it is equal to 2, you can say the function is continuous. But if it is not equal to 2, you can say the function is discontinuous. So when you differentiate x squared, you are going to get 2x. So we have 2x minus, so when you differentiate 4x, you are going to get 4, and we have plus 0, which is a constant, because when you differentiate the constant, you are going to get 0. So all over, so when you differentiate x squared, you are going to get 2x minus the constant 0. So when you differentiate the constant, you are going to get 0. So our final limit will be equal to 2x minus 4 all over 2x. So but we know that x is equal to 1. So x is equal to 1. So we can say f of x, which is the same thing as f of 1, to be equal to, so whenever we see x, we substitute it for 1. So we have 2 open brackets 1 minus 4 all over, so we have 2 open brackets 1. So in this case, we are going to have 2 minus 4 all over 2, because when you multiply 2 by 1, you are going to get 2. So 2 minus 4 will give us what? Minus 2 over 2. And this will give us what? Minus 1. So our f of x is equal to minus 1. So you can see that we have 2 here and we get minus 1. So what can we say about this function? You can say that the function is what? Discontinuous, because what? 2 is not the same thing as minus 1. So you can say the function, let me just put that here. You can say the function is discontinuous. So this is how you solve question on the continuity of a function. So you can see it is very, very straightforward. You just have to take the limits and compare your answer to what you get earlier. So can you try to solve this question and let me know in the comments if the function is continuous or discontinuous. So if we have f of x to be equal to x squared minus 9 all over x minus 3 at x equal to 3. So try and solve this question and let me know in the comments if the function is continuous or discontinuous. And until next time, keep learning, keep coding, and I will see you in the next one.